Hi, good afternoon to everyone. This is Naveen Kumar, Reddy Bogireddy, working as postdoctoral researcher in Institute of Physics, National Autonomous University of Mexico in Mexico. First of all, I would like to thank Science Father International Conference to the invitation as a presenter today. Today we are going to talk about a very important problem that is already published in one of our recent works. The title as the identification of byproducts from the catalytic reduction reaction of 4-nitrophenol to 4-aminophenol. We did a systematic spectroscopic study. Okay. In this, first of all, we want to see what is the problem, right? In this article, we focused mainly on the p-nitrophenol is para-nitrophenol or 4-nitrophenol. Generally, 4-nitrophenol appears as a white to light yellow crystalline solid. 4-nitrophenol is a member of class of 4-nitrophenols, that is phenol in which the hydrogen or the hydroxy group has been replaced by a nitro group. Okay, nitrophenol is used to make several medicines, fungicides, insecticides, and dyes. Okay, to darken the leather also they used nitrophenol. So there are several places to contaminate to come as a byproduct this nitrophenol into environment. Okay, the short-term inhalation or inhalation of nitrophenol in humans causes headaches, drowsiness, nausea, and cyanosis. And contact with eyes causes irritation in humans also. As per Environmental Protection Agency, it is classified as a toxic organic pollutant and it is carcinogenic. Moreover, as we know, well known that paracetamol, in the paracetamol, in the byproduct of paracetamol or in the subproduct of paracetamol, we can see the p-nitrophenol. Okay, the conversion of step 2, p-nitrophenol to p-aminophenol. Generally, as we know, the three-step procedure was first proposed by Mary in 1893 to produce paracetamol, and it was announced officially and approved by the government 1953 as safer than aspirin. Okay, generally this synthesis process consists of this fabrication of paracetamol consists of 3 steps. First is nitration of phenol to the conversion of nitro group and a nitro group to amino group and amino group to paracetamol. Okay. In the second step, we can see the para-nitrophenol nitro group to amino group. This is where we are going to target in this work. So why it is important? Because it can affect nervous system and brain damage in the human body. Due to its high stability and solubility in aqueous environment, it can be identified in 2 common forms in aqueous medium. So to eliminate this or to identify this problem, we are working from last several years. In that, we reached up to today in this stage by using different functional groups, effect of oxygen containing groups and the effect of different functional groups on the elimination, on the detection of 4-nitrophenol. Okay, this is our timeline, what we are for the growth in the detection and reduction of 4-nitrophenol from the last few years. So now we are going to talk about the work which recently we obtained, the results which we obtained recently, which is published also. This is like generally we use nano systems, nano catalysts by fabrication by using green synthesis methods or sustainable method by using coffee extract. We fabricated bimetallic structures like by using gold and silver hybrid structures. These structures generally we characterize by using several techniques like XRD, absorbance spectroscopy, infrared, and microscopic techniques. Here we can see the different morphology formation of two different structures. The first one is A belongs to A, upper section in the figure belongs to green synthesis technique. And later, down section in the figure, B section in the figure consists to chemical method. So in this work, we are comparing both green and chemical methods in terms of fabrication of nano hybrid structures and utilizing or using those structures to removal of 4-nitrophenol. Also, after the conformation of the fabricated nanoparticles, we used them for the reduction of 4-nitrophenol as a nanocatalyst. So in that, in A, we can see that within 150 seconds, the degradation of 4-nitrophenol. Generally, the 4-nitrophenol or 4-nitrophenol ion, phenolate ion, consists the absorbance maxima at around 400 nanometer. When it starts degrade, when it starts remove, the intensity of the absorbance get reduced or get decrease, the high intensity to low intensity. At the same time, it is a beautiful reaction. One side, the 4-nitrophenol is eliminating by decreasing the absorbance intensity. The other side, near to 300 nanometer, we can see the increasing of absorbance, a small hump that teaches us the formation of 4-aminophenol, as we talked recently few slides back about paracetamol. In that reaction here we can see. So the same thing we observed by using chemical nanoparticle also, chemically fabricated nanoparticle also. Although it is taking very less time, okay, compared to green synthesis nanoparticles. When you see the percentage of yield production of 4-aminophenol is CAS is coffee gold nanoparticles are higher compared to TR, means we are using chemical method through which famous chemical method through which method it is being 0.24 yield, means 24% of aminophenol, when in green synthesis coffee made nanoparticles produce give 31%, okay, almost 7% increase in production of 4-aminophenol. Apart from the absorbance studies, here we showed the photoluminescence also, because generally 4-nitrophenol or 4-nitrophenolate ion don't have any photoluminescence spectrum. So when it starts producing p-aminophenol, okay, or 4-aminophenol, it shows the photoluminescence activity or photoluminescence signal. So that is confirmed here, the production of 4-aminophenol with the time. Okay, and next we did a small set of reactions by using different concentrations of nanoparticles and to check the time. IT means induction time, the time it will take to start the reaction. Okay, that we can see within seconds. When you add the catalyst, within seconds, within less than 2 seconds, less than 1.6 seconds, the immediate start of the reaction we can observe. That depends on the how much catalyst you are using. And similarly, we are using different concentrations of borohydrate concentration, reducing agent concentration. According to that also, when we use almost 300 times of more higher concentrations compared to 4-nitrophenol, the induction time is less than 1 second. It is very beautiful thing that, but here we have to use a lot of sodium borohydrate, almost 300 times more concentration than 4-nitrophenol concentration. Apart from that, in this, the beauty of this work is, in this study, we found, first of all, this is the first study which we are reporting that found to showing the new byproducts formation. So those are like after the complete reduction of 4-nitrophenol to and conversion 4-nitrophenol to 4-aminophenol. So after some time, the 4-aminophenol is started degrading or oxidizing 4-aminophenol to benzoquinone, and later benzoquinone is converting to anhydroquinone. Okay, means there is still up to know the studies, the literature said only up to 4-aminophenol. But in this study, we did time and systematically how much time it is taking conversion from aminophenol to benzoquinine and benzoquinine to hydroquinone. We did in real time also, in terms of photoluminescence study also we did in the real time. And observance also, we showed up to 1500 minutes. And apart from that, we compared the obtained results by maintaining different pHs, like adjusting like 2.5 acidic medium and 5 near to neutral medium, 7.5 like neutral medium, and 10.5 basic medium. In that case also, we observed several distinguished absorbance peaks. So those are confirmed that phenol and hydroquinone with benzoquinone formations. And later on, as we know that whatever the studies we are carrying out in the laboratory level, we would like to mimic the external environment. To put in and that in mind, we use different river waters. We choose 3 rivers and we brought that water and we tested the same catalyst whether it is still efficient or not. But still, you can see in the right side figure from A to D, it is taking much more time compared to in distilled water and deionized water, but still it can reduce 100%. So it is very good to show that still the catalyst is very active in river waters. Okay, and after that we did the calculations of percentage of dating, and we can say almost 31%. Here also there is also beauty that the aminophenol production is almost consistent, either in distilled water or in river water. And the same thing here, we are reporting on small schematic representation how the mechanism is going on in the reduction of 4-nitrophenol, and after that how it is happening. Up to today, there are studies up to 4-nitrophenol to 4-aminophenol. After that, nobody showed what is happening through spectroscopic studies. In this work, we proposed for different pHs, the system, the produced aminophenol is changing from 4-aminophenol to benzoquinine and benzoquinine to hydroquinone when it is basic medium or when it is 7.5 to 10.5 pH. If later on, if it is acidic medium, the same system, the 4-aminophenol solution is converting to phenol. Okay, that we can see here in terms of the reaction. And this work is already published in the Journal of Environmental Management in this year, few months back. And for more information, you can go through this article. And if you need any doubts, if you have any more information regarding this work or any other work related to this topic, we are very happy to collaborate. We are very happy to discuss on the further. And I would like to thank, before I close the presentation, I would like to thank our collaborators, valuable persons, those who are helping us to continue doing these works. There are several peoples from India and several peoples from other countries, Mexico and United States of America and Japan. There are several country people also. We have collaborators. So I would like to thanks for your attention and the invitation. Hope you can understand the problem of this work, and we are very happy to collaborate. We are waiting for the collaboration, more collaborations to do much more beautiful works. Thank you very much once again for this opportunity. Thank you.